Looking at conditional probabilities, for this question we're told that set A and set B are two events, and the probability of A is 0.4. The probability of B, given A has happened, is 0.25. The probability of A not happening intersection B is equal to 0.2. And we're asked to find, for part A, probability of A intersection B. Okay, so if we start with part A, we know from conditional probability that the probability of B occurring given A has happened is equal to A intersection B over probability of A, but we are told that this is equal to 0.25. Well, if we want to find probability of A intersection B, all we have to do is multiply through by probability of A, and we know what that is. So probability of A intersection B will equal 0.25 times 0.4. And this will equal 0.1. Now for part B, we are asked to find the probability of complement A, or the probability of A not occurring. Well, in general, because the probability of A occurring plus the probability of A not occurring must equal 1. So this means, or this implies, that the probability of complement A must equal 1 minus P probability of A. So we are told what probability of A is, so we can use this information. And so we can find out that the answer is 0.6. Now for part C, we are asked to find the probability of B not occurring given A has happened. Well, in general, we can write this expression. The probability of B not occurring given A has happened plus the probability of B occurring given that A has happened must equal, very much in the same sense as part B, must equal 1. So this implies that the probability of B not occurring given A has happened must equal 1 minus P probability of B given A has happened. Well, we are told what this is, and we already know it equals 0.25. Now, for part D, what we can do is we can think about the idea of the probability of B occurring given that A has not happened. So, how would we go about writing this? In general, part D, we could write that the probability of B occurring given that A has not happened, using our similar conditional probability equations that we used before, we could write something like this. Well, this must equal the probability of B intersection, whatever that set happens to be. In this case, it happens to be the complement, all over the probability of the complement of A. Well, this is exactly the same as writing this, because we're thinking about the intersection between the two sets. So it doesn't matter which order we write them in. Well, we're told that that is 0.2. And we've just worked out the complement of A. The probability of the complement of A is 0.6. So this simplifies to a third. Now for part E, we're asked to work out probability of B. Well, what we can do is we can think about Venn diagrams graphically, and we know that this is the probability of B, and we know that this must be the probability of the complement of A. Well, if we combine these two and try to find the intersection of these two areas, in essence, this leads us to think about this diagram. Order doesn't matter again because it's the intersection. So we already know what this is. We've been told that as a part of the question. So we know that's 0.2. Well, all we need to find now is that part there. If we do want to find the probability of B. Well, what exactly is that part there? Well, that just happens to be the intersection of A and B. Well, we can use an earlier calculation from part A, where we did work out that the probability of A intersection B is equal to 0.1. So if we add these two values together, then we can find the probability of B. So set notation. And so probability of B equals 0.3. For part F, we're asked to work out probability of A given that B has happened. So that means we can use our conditional probability formula. Probability of A intersection B all over probability of B occurring, given that that's occurred. Well, we already know the intersection has a value of 0.1, and we've literally just worked out that probability of B is 0.3. So hence the value of probability of A given B is a third. Now for the last part, it asks, are A and B independent? Well, if the probability of B happening given A has already occurred was just the probability of B occurring anyway, then we could say A and B are independent. However, we found that the probability of B given A has occurred is 0.25. And we already know that the probability of B is 0.3. So they are not equal to one another. And therefore we cannot say that they are independent. They are not independent. That would be the solution. So not independent.